Limit definition of derivative. We are given a function f of x equals 3 plus 7x plus 4 square root of x. We need to find the derivative of this function using the limit definition of derivative. Now, when you apply the limit definition of derivative, you can consider three different functions and use limit definition of derivative, or you can just do it in one place. So I'll do this one in one place. Let's see what is our limit definition of derivative. So we have limit definition f prime x is the derivative of the function fx will be this difference quotient when you take the limit h approaches 0 is the limit definition. To work on this problem, I'm interested to complete the numerator. We have some more work in the numerator. Our given function is 3 plus 7x plus 4 square root of x. So I want to find the difference on the top first. So let's see what happens f of x plus h minus f of x. So first of all, in this function you just replace your x by x plus h. So you get 3 plus 7, then you have x plus h plus 4 square root of x plus h. This is my f of x plus h, and my f of x I can just use that one. So we have a 3 plus 7x plus 4 square root of x. So in the next line we'll be simplifying this. So when you remove the parentheses, you see 3 plus 7x plus 7h plus 4 square root of x plus h. We have nothing to do in here, leave it there. Distribute the negative sign, you get negative 3, negative 7x, negative 4 square root of x. Now cancel the terms you see possible. This 3, this negative 3 cancelled out, 7x, 7x cancelled out. So we end up with the remaining things and we plug it back in our limit definition. So let me put that one in the form. So just double check. So I have this one 7h, then I have this term and this term, rest cancelled out. So we write it in here, and then further simplification will give me limit h approaches 0, 7h over h will give me just 7 plus 4 square root of x plus h minus 4 square root of x over h. Now you can further simplify. See that 7 is a free constant, so you can put it outside. Limit is equals to 0, 4 square root of x plus h minus 4 square root of x over h. Now you can go back and understand in other examples that when you have this type of shape and you write h is 0, so the numerator is 0, denominator is 0. So that means you can do some algebraic work, and that algebraic work will be just take the conjugate of these and multiply in the numerator denominator and keep the equivalent form. So exactly I'm doing what I said. I'm taking conjugate of this with a plus sign. Now further simplification definitely will give you this is a minus b times a plus b, which is a squared b squared. So I'll apply that one and I'm writing in the top. So you can see when you square this, it will be 16 and the radical sign will be removed. When you square this, is 16x, and I keep h and this term. And then further simplification now gives me the following form. You have 7 plus limit h goes to 0. You can keep your denominator whatever it is, plus 4 square root of x. And in the top now, when you distribute 16 and simplify, you will simply get 16h. 16x will cancel out. Now this h I can cancel. When I plug my limit on the function, h goes to 0, so this term drops. So in the numerator I get 16, and the denominator I get 4 square root of x plus 4 square root of x. So that is giving me finally 16 over 4 square root of x. 4 square root of x will be 8 square root of x. And your final version of this is 7 plus 2 over square root of x. And that is our derivative for the given function using limit definition. So then look at the given function. F of x is 3 plus 7x plus 4 square root of x, and its derivative is 7 plus 2 over square root of x. Let us talk about the domain of the main function and its derivative. So when you look at the function is here, what is the restriction on this? First term, second term, nothing wrong. Only this one tells me that my x must be greater or equal to 0. But when I look at this one, I cannot have 0. So I said just say greater than 0. So for the main function f of x, my domain is 0 to infinity. And for the derivative, it is 0 to infinity. 0 is not included. So open here. And for the main function, it is closed.